Hi, and welcome to your first coaches clinic on the vocabulary of concurrent lines. The first term that we need to understand are exactly what concurrent lines are. Concurrent lines are three or more lines intersecting at one point. The point of concurrency is the point of intersection for all concurrent lines. There are four types of concurrent lines that we're going to be studying. The first are the perpendicular bisectors. Then we're going to focus on the angle bisectors, then the medians, and finally the altitudes. Perpendicular bisectors. A perpendicular bisector is a line, ray, or segment that intersects another segment at its midpoint, forming a right angle. Here's an example of a perpendicular bisector. This segment is bisecting this segment, and it's forming a right angle. This is the midpoint. When the perpendicular bisectors are drawn on each side of the triangle, they will intersect at one point. This is the point of concurrency, and for perpendicular bisectors, we call this the circumcenter. Next, we have the angle bisectors. An angle bisector is a line, ray, or segment that cuts an angle into two adjacent, congruent angles. So here we've got an angle which is drawn in blue, and then we've taken a ray drawn in black, and that is our angle bisector. It is then creating two congruent angles that are adjacent. And remember, adjacent just means that the angles are next to each other and sharing a side, and congruent means they have the same measure. When these lines are drawn on a triangle, they will intersect at one point. This is the point of concurrency, and for the angle bisectors, we call this the incenter. Next, we have the medians. A median is a segment drawn from the vertex of a triangle to a midpoint. So you'll notice that points D, E, and F are all examples of midpoints. So a median, an example would be A, D. A is the vertex, and D is the midpoint. So when all of these lines intersect, they intersect at one point, which is called the point of concurrency. And for medians, this point of concurrency is called the centroid. One thing that's special about the centroid is it is the balancing point of the triangle. So we could balance this triangle on our finger at point P, and it would stay perfectly balanced and still. Next, we have altitudes. An altitude is just another word for height. A segment that is drawn from a vertex to the opposite side of the triangle and forms a right angle is an altitude. So here's a vertex, and we've drawn the altitude to the opposite side of the triangle, and we've formed a right angle. When all of these lines intersect, they intersect at a point of concurrency. And for the altitudes, we call this the orthocenter. Now, I know that we've just discussed a lot of vocabulary, so let's summarize. There are four types of concurrent lines: the perpendicular bisector, the angle bisector, the median, and the altitude. The perpendicular bisector, the thing that is key to remember about this, it is formed by creating right angles at the midpoint of the sides of the triangle. The point of concurrency is called the circumcenter. An angle bisector is formed by a line cutting an angle into two congruent adjacent angles, and its point of concurrency is called the incenter. For the medians, it is formed from a vertex to a midpoint, and its point of concurrency is called the centroid, and the centroid is the balancing point of the triangle. Finally, we have the altitude. This is formed from the vertex, but instead of going to the midpoint like we did for the median, we go to the opposite side of the triangle and just form a right angle. Its point of concurrency is called the orthocenter. Now, I know that you have just learned a lot in a short amount of time, so give yourself a hand because you've done a great job.